You know, if you stay home long enough, you ironically start to look homeless. I mean, it really is ironic. Showing up for the class video like I'm unemployed. Oh well. Hey guys, in this episode, we're going to be going over JavaScript classes. I think it's something that most people have been introduced to, but it's always good to get a refresher on not just the standard functionality, but some of the cool features that it offers. And as always, all of the material that we go over in this episode will be on my GitHub. I'll throw a link in the description, and we'll just be in this directory number 12, classes. And if you open up the classes.html, you should be good to go. So just as a refresh, JavaScript classes are a syntactic improvement on prototypical inheritance, which are too many syllables, but we'll take a look at doing things the old way in our first example. Classes are essentially objects that are composed of attributes and methods. Attributes are things about them, methods are functions, they're things that they do. Instances of a class are instantiated with the new keyword. So if you had written a dog class, you would say const dog is set to a new dog with those parentheses. And when you're defining a class, you're going to capitalize the name of it by convention. So let's take a look at a basic example. The functionality we're going to look at is essentially a basic counter. So when it's created, you can set its starting value, and then you're able to just increment it. Now, the old way of doing things would be to write a function, old counter, and utilize the this keyword. So then when you have a new instantiation of that object, the this would be set to that specific object. So I can say const OC for old counter is set to new, ironically, old counter. And then you can see OC.count is set to 0. Now you would be able to add methods by adding them to the prototype of that function. So oldCounter.prototype.increment is a function where you take in x, which is assumed to be 1, and add it to the current count. So if I say oc.count, then that will fail because count is not a method. oc.increment, however, is. And so if I say oc.count now, that's going to be 1. I can run increment a number of times, and oc.count is going to match that. Now, if I say occ is set to a new old counter, I could say 3. occ.count has that same functionality, but the this that's being referenced here as this.count is specific to the specific instantiation. And so occ.count is 3, but oc.count is still going to equal 4. If we wanted to do this exact same thing with classes, we would say class counter and then define all of the functionality inside of that class. And so the constructor is a special method that is run when you create a new instantiation of that class. Anything you pass inside of these parentheses will be passed to that constructor. So here we're saying that starting value is going to default to 0. So if you don't pass anything, it'll be 0. And that will set this .count to the starting value. We can then define our method, increment, in a similar way to oldCounter.prototype.increment, but it doesn't look horrendous. So we can clear this off and just say const c is set to new counter. And here we can do the same thing. So we can say 2. C.count is going to be started at 2. C.count increment c.count is now 3. So basic functionality. I think it's pretty straightforward. You can access attributes through the this, and those are going to be publicly available from the code. So if I just say C, we're going to get a view of all of the attributes. And if we click on proto, we can see the methods. So increment, for example, constructor. Now, one of the biggest things that people move to right away when they're talking about classes is inheritance. And I think it's a massive cliche. I don't really like it because it's something that when I work with classes, the vast majority of the time, mostly you're not actually extending other classes. It happens, and in certain projects it might be a bunch. But I just think there's so much more to classes than inheritance, and so we'll cover that in a bit, but I don't want to do it right away. What I will talk about next is the concept of static. So static methods are bound to the class. So basically the idea of static functionality is binding that functionality to the concept of the class and not to any specific instantiation of that class. So when you create a static method, it's bound to the class, but not actually to any new version of that class. They are not directly called, therefore, by the instantiated objects. They can be accessed via the constructor attribute, but that's, I would say, generally rare. And so static methods are generally going to serve a utility purpose. And a good example of that is the array.isArray. So let's clear this off. And if you didn't know this, you can actually create an array by actually saying, say const a is set to new array. And you can even pass in starting values. 1, 2, 3. A at 0 is 1. Now, if you want to test if an object is an array, we have this static method array.isArray. So isArray A is going to return true, whereas isArray3 is going to be false. But if you were to say a.isArray, you're going to see that that's not defined. And it makes sense. The whole idea of isArray is to tell if something is an array. So if it were a method of our instantiation, first of all, you wouldn't be saying, am I an array? Because if you're able to even ask that as a product of being an array, the answer would be yes. And the idea that you need to instantiate an array just to test if a different object is an array is unnecessary. And so, again, this isn't something that you're going to use every time. I would say most classes probably don't always include static methods, but it's good to know about. And so if you do want to make it, we can cover how you would write that. And that's essentially, you can create a constructor. This is a normal method that we have here in our fortune teller. And then all you do is write static in front of that method. So let's clear that off. Let's create a new fortune teller. We'll say const ft is set to a new fortune teller where we're taking in a number as the argument that'll be passed to the constructor. And we can say ft dot say fortune. You will subscribe to this channel in 5 seconds. Bold. Now, if we want to get info about our fortune telling, that's not going to be accessible by our instantiated fortune teller. However, if we say fortune teller.info, click the bell for notifications of new videos. Interesting. And that's pretty much the basics of it. Again, this is something that's going to be very specific to any given project. If you're writing a library where you want to provide those utility methods, you're probably best off doing those in a static context. So we can clear that off and head on to my personal favorite part about classes, which is getters and setters. Why do I think they're so cool? I just think they allow for some really interesting patterns and are just an overall really powerful tool, and we'll hopefully get a good example of that now. So getters allow computed values to be accessed like attributes. Setters, on the other hand, allow for that custom functionality to be applied when setting an attribute. It's utilized by adding a keyword before a function or method whose name will be treated as an attribute. And so for that example, I created this class square. We can see that the constructor is taking in the initial width of a side of that square. And so we can say const square is set to a new square with the side of 3. Now what's important to remember is that we're writing these things as functions, but they're treated as attributes. So we see get area is a function, and that means when I say s.area, it runs a function, and what is returned is going to be the attribute value. So if I just say s.area, the value is 9, and it's taking the width, squaring it, and giving us that value. So if I try and say area as a function or a method, that's not going to work. On the other hand, the same is true for a setter. And so we can say s.area is set to 16, and now we can see s.width is 4, where before it was 3, and s.area again is going to be 16. And it's clear to understand that the only reason that our getter and setter are matching up perfectly is because we are doing that programmatically. We're not setting the area to 16, and therefore when you get the area, it's 16. What we're doing is saying when area is set to 16, this dot width is going to be the square root of 16, which is 4, and so our s dot width, as we see here, is now 4. Therefore, when we say s dot area, we are getting this width times this dot width, which is 16. And so this also allows you to reject the ability to actually set a value. So if you think of React, where in a class you can't actually say this dot state equals something outside of the constructor, but you can set state with this dot set state, and you can get the state, you just can't set it. So it just allows for some really cool patterns. And if you haven't had any exposure to getters and setters, definitely play around with it. So we can clear that off and head on to inheritance. Now, if you haven't learned about classes at all before, essentially, inheritance allows classes to inherit functionality. A child is going to extend a parent. So a parent is going to define functionality, and a child can have that functionality plus more. The parent's constructor will be called via the super and passing in any argument that you would pass if you were instantiating a new version of that parent. And you'll do that from within a child's constructor. The child can then access all the methods and attributes from the parent. So because this is such an absolutely cliche part of teaching classes, I thought it only made sense that I use the most cliche example. So what I did was create a class for an animal. So I'll say const kitty is set to a new animal, and that cat's name will be kitten. Now, this kitty is able to eat, so I can say eat cat food, and 2 seconds later, kitten pooped out some cat food. Kitty is also able to play. Kitten is playing. Now, my dog Hazel is an animal. Hazel can eat and Hazel can play, but Hazel's more than just an animal. She is an absolute degenerate, and therefore she's in a class of her own. She is a dog, And when I create her, I can say const Hazel is set to a new dog, Hazel, and she is a chocolate lab. And the fact that she's a chocolate lab, I think, is what actually explains why when she plays, she licks her butthole a lot. And so that's her version of playing. Now, if we look at our dog, we can redefine how she plays, but because she's an animal, we can also say hazel.eat. And so we can say leftovers. And just like any other animal, 2 seconds later, Hazel pooped out some leftovers. And if we're going to be accurate, we can then say hazel.play. So she licks her butthole. Now, if you're inside of a child that's extending from a different class, you might want to change how a method works, in our case, play. But you'll still always have access to those parent methods. And those are accessed with the super keyword. So we can say hazel.animalPlay. And when we call animalPlay is saying super.play, and it's accessing this version of play. So Hazel can be a cute, lovable chocolate lab as well. We can also see that Hazel has a breed, chocolate lab, and that is something that if we take our kitty, it's not there. So I don't want to go too much more into detail with inheritance. If it's something you're super interested in, there's a lot of material on it. Look into it. But as I said before, a lot of times when working with classes, you don't use inheritance a whole lot. And so I just don't think it makes sense to cover it too in depth. Now, the final main feature that I'm going to cover is the private feature, which is experimental. And what it means is you have private attributes. And what you do is you start the name with a hash, and it makes those attributes private. Now, it's worth noting that private is not the same as hidden, and we'll cover that in just a bit. And because this is experimental, you shouldn't use it without transpiling your code with something like Babel. So as long as you have a build process, like the one I covered in my video a week ago, which I will put a link to, then you're free to use this. If not, there are probably some browsers that won't support it. So for this example, I created our own MC Hammer. Now, if we take a look at Hammer, we can see Hammer's got not this, but Hammer's also got this. You can't touch this. You can see this. Can't touch it. What I mean by that is I can say hammer dot hash this, and we see that's a private field. This must be declared in an enclosing class. Whereas something like hammer dot not this, that you can touch. So why would you want to use these private attributes? Well, you can't access it from outside, but you're still able to do whatever you want with it from within that class. And so how that looks is we created privates. Now, I don't know why you would want to touch MC Hammer's privates, but I guess as long as MC Hammer's the one handling his privates, that's okay. I'm already regretting this example. So what we're seeing here is that the constructor is setting this dot hash privates to what you pass in the constructor. So in this case, we can say const h is set to new MC Hammer. And if we set that to a string private, we can log h and see privates is private, which is the string that we passed. Now, we're using these getter and setter to give us access. So although we can't access hash privates directly, what we can do is we can influence it through these getter and setters, which we wrote. And this is essentially the class having control over our access to a private attribute. And so if I say h.privates, we don't actually get private, we get private with the exclamation point. And that's what we see here. Return this dot privates plus exclamation point. And so I can say h.privates is set to nope. And if I actually pass it as a string, we can see that we are setting the value to nope. But if we run h.privates again, we see we're only able to access with the exclamation point. So again, this is just giving you more control over what you want to make accessible to objects from outside of your class. Now, this video isn't about patterns for development, but I think it goes without saying that this ability to have private attributes is extremely powerful, and if used correctly, can help organize your code in a safe way. So, what are my final thoughts when it comes to JavaScript classes? Well, classes are often viewed as merely an inheritance tool for JavaScript, but they provide so much more functionality than that. When used properly, classes can help keep your code organized, and especially readable for those pesky Java developers. If you don't have any experience with Java, it's an object-oriented language where everything happens within classes. And you have similar concepts like static, and it looks kind of similar to the JavaScript version, but it's definitely pretty different. Nevertheless, especially in my experience when back-end engineers are trying to work on the front end, if they have to use a data structure, the ones I've worked with have always preferred to write things in classes just because it looks more familiar to them. So I hope you play around with JavaScript classes. If you don't have any experience with it, it's definitely worth digging into and testing out. Now, if you did find this video useful in any way, feel free to subscribe for more content like this. Also, likes and comments are going to help grow the channel. Alright guys, that should be all for today. Take care.